Hi everyone, welcome to a new video. I hope you all are doing great. So in this video I will be discussing one IBM latest coding question. So any further delay, let's get started. This is a question that is given to us. Given a number num, two adjacent digits can be swapped if their parity are same. Okay, parity are same, that is both are odd or both are even. For example, 5, 9 have the same parity but 6, 9 don't. So now the point is that 5, 9 are the odd numbers, right? Both are odd numbers. So that means that they have the same parity. It means you can do the swapping. But in case of 6, 9, 9 is an odd number but 6 is an even number. So you cannot do the swapping because their parity are not same. Okay. I think it's clear up to this. So now let's see some examples. Okay, then so find the largest number that can be created. The swap operation can be applied any number of times. So the largest number, this is the first point that you have to note it. And the second thing is that you can be applied multiple number of the times you can do the swapping. Okay, any number of the times you can do the swapping. There is no limitation on swapping. Okay, so now let's see this example. Okay, this is the example 7 5 9 6 8 0 1. Okay, so now you can do the swapping for 5 and 9. Why so? Because as we can see 5 and 9 are the what are the same parity and they are adjacent, so we can do the swapping. Okay, so that's why we are doing the swapping. But I just wanted to explain you one more thing. Like this is the number, right? So as you can see 7 5, these two numbers, they are adjacent and they have the same parity because they both are odd numbers, right? So why don't we swap these two numbers? Yeah, you are thinking right, because if we do the swapping, then we cannot create the largest number. That is our main target, that we have to create largest number that is possible. So if you do the swapping for these two numbers, then you won't get the largest number. That's why we are not considering this kind of condition or like this kind of cases. So that's why first we are starting with 5 and 9. Okay, these two numbers we are taking. So now we can do the swapping 9 and 5, right? So I think it's clear. Suppose if you have 5 7, then we have 5, then we have 3, right? So there is no point if you do the swapping for 5 and 3, right? Because they are already in a good position, the correct position, better we can say, means the larger number is already present previously to the smaller number. So it means there is no point of swapping these two numbers. So this is one point as you should remember. Okay, then go to our next swapping. So next we will swap 7 and 9. Okay, 7 and 9 we have. Yeah, now we can do the swapping. Let's see anything else we can swap, like 7 9 7. Okay, next 7 5. Okay, they are like they have the same parity but they are in a correct position, so no need to swap. Then 5 6. Okay, they don't have the same parity, we can ignore. Next we have 6 and 8. Okay, now we can do the swapping for 6 and 8, the same you can see here. Okay, now we can do the swapping. Now it is now 8 and 6. So next we have 0 and 1. They don't have the same parity, right? Because as we know, 1 is the odd number, right? And 0 is a even number. So we cannot do the swapping. Yeah, so at the end, this is our result. I think how we are getting this result, it is totally clear to you. So if you have any doubts, then that is totally fine. If you see the solution, that would definitely help you to understand the solution, both the questions better. Okay, so now any further delay, let's go to our IDE. Okay, now we come to our IDE. Okay, so same example I have taken here. So now to solve this question, what we can use, we can do the recursion. Why so? Because as you know, we can do multiple number of swapping. There is no limitation on swapping. Like you can use any for loop and or like you can use any while loop. Like if they specified that you can do the swapping only for 3 times or only 4 times, then what you can do, you can do while loop. Under the while loop you can give some condition like the iteration should be less than or equal to 4, but you don't have that kind of limitation, right? The point is that you have to find out the largest number that is possible. That is our main target. So for that, what you can do, you can use recursion. Okay, I think the motive is clear to you, why you are using or like why we are using recursion. Okay, so now how you will use the recursion concept, that you will understand when I will write down the code. Okay, so now let's see how we can do. Okay, so now I will create another method. Okay, public static, right? So because as I don't want to create any object and all, that's why I am using static. You feel free to create any like non-static methods as well, like string that will be returned. Okay, and then okay, what is the spelling of string now? string string. Yeah, I think it's correct. Okay, string, then like suppose I am taking test, right? Test, and then string s, right? So okay, return null. Okay, so what I was saying, like we will call this test method here actually, right? So like suppose here you have num, right? So the point is that means via static methods you can call only static method. No static methods you cannot call via a static method, right? So I think that's why it would be great if you use static, right? So I think it's clear up to this. Like suppose if you are not using this static now, then you cannot like use it. It will definitely give you exception. Like what is the point, right? So there is no point if you use try catch and all, so it won't help you. Okay, okay, let me to control Z. Why this yeah, now it is working. Okay, so the point is that you have to use static, yeah, in nutshell. So okay, I think something went wrong. See how we can solve. Okay, just let me to remove this thing. So what we have discussed, that same we will code this here. Okay, so we will use one for loop. Simple, right? Int I equals to 0, I less than s dot length. Okay, -1. Why I am doing this -1, that I will definitely explain. No need to worry. Okay, then here I will use two numbers. I have to use, because you have to take two adjacent numbers, right? So char at, okay, char at, okay, why no suggestions is coming? Yeah, and 0, not 0 actually, I, right? And then int I2 equals to n2 equals to char at of I plus 1, right? So now I think you can understand why I am using this -1, because every time I am taking I and then I plus 1, otherwise you will get exception, array index out of bounds exception you will get. So suppose you have A, B, C, D, right? And now you are in this D. Okay, so if you don't do this, right, if you don't do this and your I is here, and when compiler will try to compile this line, that time it won't find any element for I plus 1, right? So that time you will get one exception. Okay, to avoid that I am doing this -1. I think and this is clear. So now what we will do, now we will check some conditions. Okay, before that I need to convert this properly. Okay, so now like I am doing nothing, I am just converting our character into the integers, nothing. Okay, so now what will be our first thing, we have two adjacent elements now. Now what is the thing that we have to check? First thing we have to check that two elements have the same parity or not, right? So n1 remainder 2 equals to 0 and n2 remainder 2 equals to 0. And one more thing you have to check, that is n2 should be greater than n1, then only we will swap, na? Otherwise there is no point. I have explained that thing, right? So now just copy, Ctrl Shift F. Okay, so now you have to check, okay, 0. Now this is for even numbers, right? So same you have to do for odd numbers as well, right? So yeah, I think this is clear up to this. So now again we will do one more thing. We will take one empty string, okay, that will be our resultant string. Okay, so now if this particular condition gets satisfied, then what we will do? We will do one thing, that is plus equals to what? Plus equals to is dot char at of I plus 1 and then you have to make this string, right? Is dot char at I. Yeah, okay, I think it's clear, because so you have to add the larger element, then you have to add the smaller element, and as we know this n2 is bigger than n1, that's why we are executing this if condition, right? So you have to add the bigger element, like larger element, before the smaller element, right? So I think this is clear. You have to do the same for odd number as well. I think it's clear. So now you have already added I plus 1 and I, right? So now what next we have to do? There is no point of checking the same number again, right? Suppose you have this, like I am taking this number, right? 7 and 5, right? So 7 and 5 you have checked, right? So suppose, okay, no, take 7 and 5 for sake of argument. Let's take 5 and 9. Okay, you have 5 and 9, so you have 5 here and now you have 9 here. Okay, so now what condition will satisfy? This condition is satisfied, right? And now you will add this 9 before and then you will add 5, right? So now you have already swapped this, so now there is no point of again checking this 5, okay, because you have already checked for 9 and 5. For these two numbers you have checked for the one iteration, so I don't want to check for these two numbers again. Okay, so that is my motive. So now I am doing I plus, because I have already checked those two numbers and that is totally working fine, means like we can add these two numbers in a particular string. Okay, suppose these two conditions haven't satisfied, then what we will do? Then we will do only one thing we will do. Okay, we have to do na else if, not like only else, right? Because if this particular condition not satisfied, then only we will go to this condition. Okay, so now again else if else. So if these both two conditions don't satisfied, then what we will do? Then simply we will, whatever element we are currently working on, we will just add that particular element. Okay, so plus equals to s dot char at of I. Okay, right? Because suppose for the first two numbers 7 and 5 we have, right? 7 and 5 we have. So although this condition will satisfy, first two conditions, but this condition not satisfied because 7 is greater than 5, right? So this if condition not satisfied, then we will come to our else block. Then that case we will only add 7 in our resultant string. I think it's clear. Okay, okay, then moving on. So now if you didn't notice that, I wanted to notice one thing, like suppose every time you are taking two adjacent elements, right? So like suppose 5, 7, 5, right? Then again 9, 6, right? Then again 8, 0, right? So now what will happen for this one? Right, because you are also not considering this one, because you are executing store length -1, so you cannot take this one, right? For this like using this for loop, you cannot iterate this particular one. Even thing can happen, like suppose I am taking random numbers, okay? So like what is the number we have? 1, 2, 3, 4. Okay, I'm just removing this part as well. So suppose if this if condition if satisfied, then this is well and good, you are adding both numbers. But suppose for the last pairs, for the last pair, any pair you are thinking, for the last two pairs you have, okay, but for that two pairs this if condition is not satisfying, also this if condition is satisfying. Because also you are adding only the ith element, you are not adding the I plus 1 element, right? Like I don't know whether it will work or not. Like suppose you have this 3 and 4, right? So like this 3, 4 is you have they don't have the same parity, right? Like first you have 1, 2, okay? So obviously this else block will satisfied, right? So now because 1 is the odd number and 2 is the even number, right? So this else block will satisfied. Again you will add 1, right? So now again you will have like 2 you will have, right? And 2, 3, again this condition will not satisfy, to this 2 will be added, means this else block will be added, right? So now again you will have 3, okay, because again this else block is satisfied, but we are iterating -1, right? So now this for loop will be ended, but you are not iterating this 4, then how will get this 4? So as you can see, there may possibility, I am not saying there are 100% possibilities. Like suppose you have like suppose if you have 4, 4, right? If you have 4, 4, or like not 4, 4, like suppose you have 4, 6, okay? So now for 4 and 6, in that case this if block will execute, and in that case you will add these two numbers. In that case you will have like 6, 4. In that case there will be no like regret, like why I am traversing store length -1, there won't be any regret. But you will have when your last two elements are something else, like you have 3, 4, in that case you are not iterating this 4. So what else we can do for this? We will just do one thing, we will check if our I is equals to if length -2, it means that there have another one element is remaining, right? Because we are like, although we are adding two elements, but again we are incrementing our I, right? So now we are checking, like if I is equals to store length -2, it means that there is one element remaining, okay? So that means that you have to add this another element, okay? So s dot char add of +1 you can do, okay? So yeah, I think it is clear. So now what we will do? Now we will do our recursion. So now whatever element we will get from this for loop, okay, whatever element we will get, this is our for loop ending. Now we will check. So now it may possible, like as I have previously described, like if we have 1, 2, 3, 4, then there is no point of swapping and all, right? Because any conditions are not satisfying, so you have to return the same element. So this is one thing that you should know and you should remember while solving this question. So now what you can do, like if our this is our let's say primary value, right? The primary value for the string, right? So if s not equal if you want to check the equals, then equal string, then you have to use equals method, right? If s is equals to race, then what will do? Okay, now why it is giving me error, that I have to check. Okay, sorry for that. You have to use these race actually here, not inside the for loop. Yeah. So now if is equals to race, then what we will do, we will just return our whatever you want. Okay, if they both are same, right? If it is not, then we have to do recursion. Okay, as I have shown you, like after this number you will get the same string again and again, right? If you think it, after some swapping and all, you will get same string again and again, because this is the one number that can be formed, that is the largest number, right? So now what will be our like terminate condition if our s is equals with race? Okay, let me just show you the same in our Eclipse. Like if our s is equal with race, although it may possible like the starting element or like starting string is like even is starting string we have to return, because we cannot do any swapping and all. In that case, for race value will be also same like res only, right? So this will be our terminate condition, because after some swapping and all, your race value or like your resultant string will be same again and again and again, right? So if it is not equal, then we will do the recursion test of race. We have to pass, right? Because if they are not equal, okay, if they are not equal, then we will do the recursion. Okay, so for better understanding, what we will do now, we will do one thing, sys out, we will print our s, okay, and then also we will print our what we will print our race as well, so that you can easily understand how this is actually working. So now just run this code. Okay, so suppose you have this number. Okay, so now just run this. This is our s value. Okay, so no problem, this is our input value only, right? So this is our resultant value. How this is coming? Like you have like we have swapped this 5 and 9. Okay, now it is 9 and 5. But if you see, like for the first time this condition has satisfied. Okay, so have we used only any break and all, like we will come out from the for loop after one swapping, like, so it means that in one iteration we can do multiple swaps if it is possible. So the same we have did here also. So you can see we have 6 and 8. So we have swapped this 8 and 6 as well. These two numbers also we have swapped. Okay. So now moving on. So now this race value means the resultant string is now become our s value for our next recursion. Okay. This is our recursion call, right? This is our recursion call. So now you can see, now we are calling this test with this race. Okay, so this race value is now become s, right? And now s is our null. Oh, okay, not null, this is our empty string. Okay, not a null string, this is an empty string. Okay, so now what we can see, like this is our s, right? I think that is clear. So whatever operation we are doing, that you can see, now we can see these two numbers have swapped only, right? And all the remainings are same. You can see same here also. Okay, let me just do one thing. Let me just, yeah, I think that is more visible for you right now. Okay, so this is clear. So next, this is our next recursion call, right? Our latest trace value. So now it will be the s value for our last recursion call. Okay, let me just minimize this console little bit. Okay, so now this is our s, right? So now this is our s. Okay, so now our s is null and our s is this value. Okay, so in this particular for loop, whatever operation we are doing, we will get this race. Okay, so the point is that if you see this race and this s both are same. Okay, because the point is that this for loop is not working anything. Why so? Because this if condition unsatisfied, because if you see this particular number, if you think like if a number is in the correct position, so for the last recursion call, if you see these two numbers are same, a number of the times you will do the recursion, you will get same values for s and res. So there is no point of do the recursion unlimited number of the times, right? Because as we can see, these numbers are both same, because whatever value we are giving as a input, the same value we are getting as a output, right? Because this is s we are giving as a input and this is our s as we are giving as a output, both are same, right? So there is no point of doing the recursion again, right? So now what we can do, we can just return our value. Okay, see the output in the ppt also. Okay, the ppt also you'll get the same output like 9758601. okay, let me check the same here also. 568, yeah, we are getting the same output. Okay, mean it is working totally fine. Okay, then just comment these two lines as well. So now just run this. Okay, now you have to provide the input. Okay, so for any input you can test, it will definitely work. Okay, so there is not a problem. So yeah, I think this is totally clear to you, like how it is working. Okay, so if you still have any doubts regarding this question, you can feel free to ask me in the comment section. So yeah, that's all for this video. If you like my videos, then don't forget to subscribe to my channel and like this video. So thanks for watching and see you in the next video. Bye bye.